Pluto is a faraway, elusive, and less conspicuous planet that was once considered part of our solar system. However, recent groundbreaking statements from prominent astrophysicists like Neil deGrasse Tyson and Michio Kaku have brought Pluto back into public discussion. They have proposed that this icy planet may be heading in the direction of a potential collision course with Neptune. However, how could such a situation exist? And what would the consequences be of such a monumental event? Are we witnessing an unusual, unpredictable phenomenon? Or is there something more to this impending cosmic disaster? Join us as we explore the possible outcomes of a Pluto-Neptune collision. Pluto, which was once thought to be a planet but is now redefined as a dwarf planet, continues to be a subject of interest and investigation in the vast universe. Recent speculations from leading experts have suggested that Pluto's orbit is alarmingly close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku have warned that a catastrophic encounter between these two celestial bodies could pose a significant risk to Earth. But how could Pluto even be involved in such a collision? Pluto's orbit around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete one full orbit, and since its discovery in 1930, Pluto has not yet completed a single full revolution. However, the intrigue doesn't end there. Pluto's orbit is characterized by its distinctly elliptical shape, straying far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more unusual is its tilt. It is inclined at an angle of 17 degrees to the plane of the solar system. This gives Pluto's path a far more erratic trajectory compared to the more orderly orbits of other planets, complicating its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is where it comes into contact with Neptune's. For roughly 20 years during each orbit, Pluto actually travels closer to the Sun than Neptune does, defying conventional expectations of their relative positions in the solar system. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational forces exerted by other planets. After Pluto's discovery, astronomers quickly set out to understand its strange orbital behavior. Contrary to the orbits of the other planets, which are in close proximity to the solar plane, Pluto's orbit stands out because of its steep slope and extreme irregularity. The puzzle deepened when it became clear that Pluto's orbit intersects Neptune's. Despite this, Pluto's orbit remains stable, demonstrating the intricate dynamics of celestial mechanics and the so-called three-body problem in space. Comprehending how objects like Pluto, Neptune, and the Sun interact gravitationally is key to this scenario. It's like trying to predict where these objects will be based on where they started and how they influence one another. The stability of planetary orbits is ensured by the concept of non-concurrent libration. In the case of Pluto and Neptune, this means that every time Pluto crosses Neptune's orbit, the two bodies are always positioned at least 90 degrees apart. This spatial separation prevents a collision between them. Another contributing factor is orbital precession, which refers to the slow movement of a planet's orbit over time. For Pluto, this means that when it comes closest to Neptune or any giant planet, it is positioned well above their orbital plane, providing another layer of defense against potential collisions. An additional factor at play is the VSK wobbling effect, a concept named after three researchers, Vashkov, Sidorenko, and Krasovsky, who studied how celestial bodies interact with one another's gravitational pull. Pluto's wobbling effect explains why its orbit, though seemingly chaotic, remains stable over long periods. The gravitational tug between Pluto, Neptune, and the Sun ensures that Pluto's orbit remains relatively smooth despite its irregular shape. The VSK wobbling effect shows that even in the most unpredictable environments, underlying patterns and forces maintain stability. This three-body problem is crucial to understanding Pluto's orbit, its relationship with Neptune, and the behavior of distant objects in our solar system. Numerical simulations conducted in the late 1980s revealed that Pluto's orbit, despite the stabilizing forces at play, is actually quite erratic. Small deviations in its initial conditions could lead to significant differences in its path over centuries. Nevertheless, these simulations also showed that, over incredibly long timescales, millions or even billions of years, Pluto's orbit remains stable. To fully grasp the dynamics between Pluto and Neptune, it is important to consider the gravitational influence of the giant outer planets like Neptune, Jupiter, and Saturn. Neptune's influence is significant, as it governs Pluto's orbit in a unique resonance. For every 3 orbits that Neptune completes around the Sun, Pluto completes 2. This gravitational resonance aids in maintaining Pluto's orbital stability. However, Neptune is not the only player in this complex equation. Jupiter's massive gravity also plays a key role in stabilizing Pluto's path, while Saturn further contributes to this dynamic. These forces working together ensure that Pluto remains on a steady course for potentially millions of years, keeping it out of harm's way from Neptune's influence. Without these forces stabilizing the solar system, planetary orbits would be much more chaotic, with planets potentially colliding or being ejected from their orbits, causing catastrophic consequences across the solar system. The possibility of Pluto colliding with Neptune in the future emphasizes the complexities of celestial mechanics and the importance of studying orbital stability. By understanding these intricate dynamics, we gain a better comprehension of how the solar system works, the role of gravitational forces, and the behavior of distant celestial bodies. Despite its seemingly chaotic orbit, Pluto's path is a testament to the delicate equilibrium of forces that keep it in place. Exploring space often leads to surprising discoveries, and Pluto's irregular orbit serves as a prime example of the mysteries of the universe. The idea of orbital chaos illustrates how a celestial body's orbit can be highly sensitive to its starting position. In Pluto's case, even minor modifications to its position or speed could drastically alter its long-term orbit. Automated simulations have proven invaluable in helping scientists study these behaviors by modeling the ways in which Pluto and other objects like Neptune interact through gravitational pull. These simulations show how even the tiniest adjustments can have significant long-term effects on planetary motion. Conditions can have a significant impact on Pluto's trajectory. Though Pluto's orbit is stabilized by mechanisms like libration and precession, simulations have shown that Pluto's orbit is far from consistent. Small deviations in its initial conditions can lead to vastly different outcomes, making long-term predictions about its movement extremely challenging. Despite this apparent chaos, Pluto's orbit remains relatively stable over geological timescales, billions of years, suggesting that even in the midst of seeming chaos, there is an underlying order to Pluto's motion around the Sun. Predicting celestial movements, especially for objects with Pluto's irregular orbit, is a massive challenge. The inherent unpredictability of these systems means that any long-term forecast contains uncertainty. Numerical models help us comprehend and anticipate these movements, but their accuracy depends heavily on precise initial conditions. Even a slight error can lead to completely different outcomes, making it difficult to predict Pluto's future trajectory with confidence. Aside from the chaotic nature of planetary orbits, Pluto's story serves as a reminder of the dynamic, ever-changing nature of the universe. Despite the many advances in our understanding of space, Pluto's case demonstrates the extent to which we are still learning. Grasping the gravitational influences of the giant planets on Pluto's orbit gives us important insights into the broader mechanics of the solar system, showing how the position of each planet can significantly affect the course and stability of others. So, why are prominent astrophysicists raising concerns about a possible collision between Pluto and Neptune despite all these stabilizing factors? Neil deGrasse Tyson, a leading astrophysicist and one of the figures responsible for Pluto's reclassification from a planet to a dwarf planet, offers an insightful perspective on the ongoing mysteries of our solar system, including Pluto's future. Tyson has played an important role in reshaping the public's perception of Pluto and understanding its position in the changing landscape of planetary classification. Tyson examines Pluto's reclassification not as a loss, but as an essential adjustment based on our expanding understanding of space. His approach to celestial mechanics sees discovery and evolution as one and the same. He views orbital complexities like Pluto's as indicative of how much more we have to learn about the universe. Although Tyson remains optimistic about the study of space, his views on Pluto's potential collision with Neptune suggest that there are still many unanswered questions. Will Pluto collide with Neptune, Or is this just a brief confusion in the ever-evolving cosmic system? Only time and further research will provide the answers. For now, we are left with even greater curiosity about how much remains unknown in our own solar system. The potential for a Pluto-Neptune collision invites further examination of the mysteries of the universe and challenges our understanding of planetary dynamics. The possibility of two celestial bodies, containing vastly different properties, colliding raises intriguing questions about how the solar system evolves through gravitational interactions. A collision between Pluto and Neptune would not only have major implications for our understanding of planetary behavior but would also provide valuable insights into the solar system's evolution. To understand the dynamics of a potential impact between Pluto and Neptune, it's essential to consider the characteristics of both planets. Pluto, despite its designation as a dwarf planet, contains a variety of elements and compounds in a frozen state. The extreme cold of the outer solar system covers its surface with nitrogen ice, while its atmosphere is primarily composed of nitrogen, methane, and carbon monoxide. In contrast, Neptune, a massive gas giant, consists mainly of helium, hydrogen, and other lighter elements, with a deep, dense atmosphere. A collision between these two vastly different bodies would undoubtedly have profound effects on both planets, potentially creating an event visible across vast cosmic distances. However, it is essential to keep in mind that Neptune's gravity is not the only stabilizing force at play. Jupiter, the largest planet in the solar system, exerts a significant gravitational pull, contributing to Pluto's stable orbit and preventing it from venturing too close to Neptune. Saturn's gravitational influence further complicates interactions in the outer solar system, making a devastating collision between Pluto and Neptune unlikely. While Neptune's gravitational pull plays a key role in maintaining Pluto's orbit, the intricate gravitational connections with Jupiter and Saturn further ensure that Pluto's path remains steady. However, research has shown that the connection between Pluto and Neptune is not straightforward. Pluto and Neptune are in a gravitational resonance, meaning Pluto completes 2 orbits for every 3 of Neptune's. This resonance creates a natural barrier that prevents them from colliding. Often described as a dance of gravity, this mechanism ensures that Pluto and Neptune's orbital crossings never result in a collision. This phenomenon is a remarkable example of how celestial bodies can maintain a harmonious relationship despite chaotic forces at work. Yet, the delicate balance of space is not guaranteed. Small shifts in the positions or velocities of these planets could disrupt this resonance, leading to unpredictable consequences. Such changes could be triggered by external forces, like the gravitational influence of an undiscovered planet or a passing star, or by internal events such as tidal forces gradually altering the orbits of these bodies. Continued study and observation of Pluto, Neptune, and surrounding solar system objects are necessary for comprehending the long-term stability of their interactions. As technology advances, scientists will refine their models and gain a clearer understanding of the dynamics between these distant objects. New data may shed light on the balance that keeps Pluto and Neptune from colliding, or it may uncover entirely new forces that could alter their relationship in the future. One key factor that has emerged is the possibility of an undiscovered object influencing Pluto and Neptune's orbits. This hypothetical object, often referred to as Planet 9, is believed to exist in the far reaches of the solar system. Some scientists speculate that its gravitational pull could alter the orbits of objects like Pluto, potentially pushing them toward new paths that might destabilize their current positions. While the existence of Planet 9 is still a subject of debate, its potential impact adds another layer of complexity to the situation. Besides gravitational interactions between planets, it's important to consider the broader context of how the solar system itself is evolving. The Sun, being the dominant gravitational force in the system, is gradually losing mass through solar wind. As the Sun loses mass, the orbits of all planets, including Neptune and Pluto, could gradually expand over time. This process could shift their relative positions and affect the long-term stability of their orbital resonance. Furthermore, the outer solar system is not a static place. Objects like comets and other small bodies are constantly passing through, exerting their own gravitational influences. While such events are uncommon, their combined effects may contribute to Pluto's dynamic orbit, which continuously adjusts in response to the gravitational interactions between planets. On a more speculative note, a large-scale event, such as the collision of two smaller bodies in the distant reaches of the solar system, could also play a role in shifting the trajectories of objects like Pluto. If such an event were to occur, it might trigger a chain reaction with unforeseen consequences for Pluto's course. This highlights the chaotic nature of celestial dynamics, where even barely noticeable events can lead to large-scale changes over time. Understanding these potential scenarios requires advanced simulations and continuous observation. While we currently have a solid grasp of Pluto's orbital behavior, the true nature of its future trajectory will depend on multiple factors that are difficult to foresee. The ongoing study of Pluto, Neptune, and the outer solar system remains a crucial component of modern astrophysics, offering insights into the forces that govern our cosmic neighborhood.